So in this video, I will be introducing you to the idea of signals. So let us begin with the formal definition of the signal. Okay, it can be written like this, that signal is any physical quantity that varies with time. But instead of talking too much about this definition itself or this formal way of representing the signal, I can explain this better with the help of an example. So I will take one standard example of a signal. Supposing if I have, say, this horizontal axis as t, and say on a vertical axis I plot voltage. Okay, so if I plot time versus voltage, okay, voltage is a physical quantity and it is plotted against time t. Okay, so this is nothing but a voltage signal. Okay, we're going to encounter these type of signals a lot. So let me give you an example of how voltage signal will look like. Let's say we have a voltage signal, okay, which is say 5 volts in magnitude, and if you observe, it is 5 volts constant throughout. Okay, and it is starting from t is equal to 0 onwards, it is 5 volts. Now this is the graphical representation of the signal, but we can also represent the same signal in a mathematical form, and that is more important. See, I write like this: voltage is a function of time, v is a voltage, it's a function of time, and this value is 5 volts, and that is only for t is greater than or equal to 0. So what if your t is less than 0? Okay, on the other side here, so on the other side the value is simply 0. So here the voltage is 0. So basically I just want to show you that this is the graph representation of the signal and this is the mathematical representation of the signal. This was just one example just to give you an idea of what voltage is. Now I'll give you one more example. Okay, and now of course I can take the next one as, again, this is a horizontal axis which is time, and on a vertical axis I write down I. I stands for current, right? So if I take a time versus current and say the current has got this shape, okay, you can clearly see it's a sinusoidal current, right? So I can simply call this as a AC current signal, right? So this is the example of a signal, right? And it's a current signal. So how do I write this down in a mathematical form? It would be I, which is a function of time t, and that is nothing but sine t. It's a sinusoidal waveform, and this is for t is greater than or equal to 0 again, but when t is less than 0, it becomes 0. Now these are just two formal examples of signal, just to show you how signals look like. Now by looking at these examples, we just want to draw a few conclusions here. Now I want you to understand this part very well. Now this is the most important part. So let us write down conclusion of this discussion. And the conclusion I can make here is, can I just say that a signal is a graph, because we have got both the graphs over here, and that is the case most of the time. So I'll write down most of the time. Okay, signal can be expressed mathematically. We can have a mathematical expression, like we have this a mathematical representation of current signal, and this is the mathematical representation of voltage signal. This is how we write down mathematically all the signals. But now the most important conclusion of all that you have to understand, and this is the point that I really wanted. Let me make one more. There are 5 stars over here. This is the most important point of all, that whenever you say signal, okay, in your head you should understand that when you say signal, it is nothing but some information. Now I want to explain this point properly. Now what do I mean by that? When I say signal is an information, if you look at this voltage signal and you see the voltage is constant 5 volts throughout, right? So now by looking at this voltage signal, you know that this signal, the voltage signal, is nothing but output of a DC battery. It's a DC voltage, it's a constant voltage, right? So it is a DC voltage battery of say 5 volt, which is what this is a positive and this is negative. I hope you already know this. So it's a signal out of a DC battery, right? Now if you look at the other example that I've talked about, which is a sinusoidal waveform, okay, where do you get the AC current signal? That is nothing but the power supply, right? So the power supply that we get at our home is nothing but a AC current signal. So that is just an example. Okay, so by looking at a signal, you always get some sort of information, and even the vice versa is also true, that if it is information, you can very much call it as a signal. So it is, signal is an information, and vice versa. It means any information can also be written as signal. Okay, this is the point that you have to understand. Now, the most obvious example would have been, forget about voltage and current signal. The most obvious example of signal is the traffic signal, right? Now, why do we call traffic signal? Now, it's a good case actually. We should discuss about that. The traffic signal doesn't have any graph, right? Doesn't have any mathematical expression whatsoever. So I just wrote here, it's most of the time going to be a graph. Most of the time it can be expressed as a mathematical expression. But then this is the most important point, that that signal is an information, and so is a traffic signal, right? So if you see a red signal, you are supposed to stop ideally, isn't it? So that signal is giving you some information. I'm signaling you, in a sense, what? I'm just giving you some information. I hope you understood. That's the basic idea. So henceforth, whenever you hear word signal, okay, no matter what it is, you just have to understand it is a some sort of information. It's a some information expressed in some form, mathematical, graphical, okay, whichever that can be. But then that's the basic idea. Now we should go to the next example, and I'm just going to show you a signal, okay, which is going to look completely different. And I feel this will give you a better perspective. So we are moving on to our third example. Okay, so here is it. Say, supposing if you have a photograph, okay, let's say this is someone's photograph, okay, let's say it's my photograph, whatever. So now this is basically nothing but an image, right? And now my question to you is this a signal? Okay, if I ask you a question, whether an image is a signal, it's a very good example actually. So here you have to basically recall that any information is nothing but a signal. So even if you look at this image, I mean, you look at the image and you say, hey, it's my photograph, right? So you basically get some information, and hence even image qualifies as a signal. All right. It is just that it is in a different type. It's a different type of signal. It is not a one dimensional. It is rather two dimensional signal. So you have this as x-axis. Say this is your y-axis, and on xy axis. Now this is the image over here. So understand it is a two-dimensional signal. Okay. This is some advanced form of a signal. I just wanted to tell you about this. But then this is just a point that you have to understand.